Okay, lesson 3.3, completing the square, part B. This is going to be very much like the last one, except we get into some of the more fun stuff. We get into the cases where the a value is not 1. So almost all the same steps, we're just adding a step or two at the beginning that we didn't have to do before. Before we get started, you should try and figure out which one matches with which one. There's something in this column which is the exact same function as something in this column. So pause the video, see if you can do that. Okay, it's a little bit hard to tell which is matching with which right just from looking at them. You might be tempted to look at the C values first and the C values over here, but there doesn't seem to be any kind of a match. The A values, though, are kind of an indicator. These ones both have a -1 A value. These ones both have a -1 A value. So those two match with those two, and the 3's match with the 3's. And you probably want to expand to find out which is which. So you could take any of these values, you could actually expand it out. I'll just do that with one of them. I'll take this first one. So negative x minus 2 squared means times itself, plus 7. So that is x squared. Minus 2x minus 2x makes minus 4x, and plus 4, with the minus still in the very front. So you rainbow the minus across. Minus x squared plus 4x minus 4 plus 7 is negative x squared plus 4x plus 3. So the top one should be this one right here. And our other minus guy is the one down there. The first 3 is the one at the top. The second 3 is that second to last one. Okay, in order to convert from standard form to vertex form, if a is not equal to 1, it will be necessary to, the very first thing that we need to do is actually to common factor out the a value. So every time if you have a that's not 1, which is actually the case for all of these things, you're actually going to be common factoring out the 3 or the -1 into the front, just like you see it here. That's always going to be our first step. So all of the steps for completing the square, make sure that's away. This method is pretty much the same every single time. So once you've done it 3 times, you should have it pretty comfortable. Once you've done it 10 times, you should never get it wrong again. So lots of practice, but it should be pretty manageable. Number 1, you have to have the quadratic in standard form. So if you don't yet, you need to get it into standard form. Maybe that's from a word problem, or maybe you have it in factored form and you have to expand. Number 2, group the first 2 terms together. We care about the first 2 terms. We don't care about the third one. Get the third one out of the way. Toss it out. Number 3, this is our new step that we didn't have before. Factor out the leading coefficient from the first 2 terms, no matter what. So you're not picking the common factor. You're always taking the a value and treating that like the common factor, even if it doesn't really work, even if it's going to mess up your b value into something else. We're always going to pull out whatever the a is. Number 4, add and subtract the square of half of the coefficient of the x term. Oof, that's really complicated. This is our term b over 2 squared. This is, you have to memorize that. That's always what we want the c value to be. C star, we call it. That is our ideal c value, is b divided by 2 squared. Group the perfect square trinomial by removing the subtracted number. So we keep only the ones you want, and then write it as a binomial, and then simplify. So let's see how that works. It makes a lot more sense in context. So step number 1, we care about the first 2 guys. We don't care about the 24. 24 is gone. We need the first 2 terms to be a perfect square. So we're going to write it y equals 2x squared plus 16x. Those are the guys we like. And sometimes for sake of clarity, we chuck that c value that we do have way out here because we don't like them. Number 2, we need to common factor out the 2. Doesn't matter if it is a common factor. In this case, it is a common factor, but no matter what, common factor it out. Just out of the first two terms that are in our brackets. So y equals 2 in front. That leaves me an x squared, and that leaves me an 8x. I like to leave a bracket, leave some space there, because I like to do the next step on the same line. Once you've got these two, now we need to find out what c star is. So c star is equal to b over 2 squared. That is 8 is our b value. The b value that you have remaining inside the brackets we care about. So b divided by 2 is 4, squared is 16. So we want 16. If we had 16 there, everything would be peachy. But we also have to subtract 16, and it has to be inside the brackets. If it were outside the brackets, it wouldn't be equal to each other. So it has to be inside the brackets. Most people are pretty good with this part up until here. Now here's the hard step. Here's the step that people will tend to forget. We need to only have the perfect square inside the brackets, so we need to get rid of this guy. But now that we have a common factor, to get rid of him, you actually have to multiply him by 2. So y equals 2. So on the outside, it's going to be negative 16 times 2 is negative 32 plus 24. So that's the 16 gone. Now everything left inside is all just a perfect square. X squared plus 8x plus 16. So let's write that as a perfect square, and let's collect the like terms there. Perfect square means it's a single one squared. On the outside, it's going to be 6, 8, negative 8. And on the inside, it's going to be x plus 4. It's always half the b value or the square root of the c value. Either way, it should be the exact same thing. It's kind of like the in-between in this form. Like you do take it in half. That's going to be the number you end up here, and before you square it. After you square it, it ends up here. So that's it for that one. If you're feeling comfortable, you should pause this and try and do it on your own first. What's the maximum value? Oh, let's state some answers about this. So the vertex, I usually pull out the vertex before I try and answer these. The vertex is negative 4, negative 8. What is the maximum value, and when does it occur? It's actually opening up. So it's actually a minimum value in this case. So it's a minimum value of negative 8 when x is equal to negative 4. Okay, sorry, now you should try this one if you're feeling comfortable. If not, you can just watch. First thing you want to do is rearrange this so it's in the right order. Y equals negative 4x squared. The sign always goes with the number after it, so the negative comes with the 4, plus 9x minus 2. I can't do anything till it's in the right order. Next thing you're going to do is common factor out negative 4. It is not a common factor for the first two terms, but we need to treat it like it is. So we're going to pull out negative 4. We're going to leave the negative 2 at the back. We don't care about the negative 2. He's not the right kind of guy. X squared plus 9 divided by 4. Well, that's negative. We pulled out the negative and we pulled out the 4, so it's actually negative 9/4 x. If you want to do it as a fraction. If you want to do it as a decimal, well, my 20-1 people, you should be able to do this as a fraction. I'd want to see it as a fraction. 20-2, you can turn this into a decimal. That'll be just fine. As a decimal, that should be just over 2 point something. And now we need to find our c value. So c star is equal to b over 2. So negative 9/4, all divided by 2, squared. Nice and easy fractions, right? So that dividing by 2, I always have to rewrite it like this. Negative 9 over 4 divided by 2 over 1 means flip it. The 2 goes onto the bottom, so it equals negative 9/8 squared. And to square it, you square the top and you square the bottom. So the top is 81 and the bottom is 64. 81/64 is our C value. The negative disappears when it's squared as well. A little bit hard to do this stuff. Hopefully you can quickly remember all your fraction rules. So C value is plus 81/64. Every single time the C value that we want is the positive, because when you square it you can only get a positive answer. But there is a negative one here that we don't like. So next thing we have to do, get rid of the one that we don't like. So negative 1/64 times negative 4. So it's going to be positive. Let me get my calculator. So the 4 actually joins the top, and we're going to cross cancel. So 4 divided by 64, which is a fraction. Does 64 divide by 4? Yeah, 16. So this is actually 81/16. It's going to come out positive. What's left inside? Let's turn it into let's reduce it. This is our perfect square. And the perfect square is exactly half that, or the square root of that, which should be this guy here, negative 9/8. So x minus 9/8. So if you did your C calculation in steps, then you should have the number already. So that's that. Now let's tidy it up a bit. Negative 4x minus 9/8, all squared. And on the outside, we need to make a common denominator, I mean. So the 2 is going to be like 32/16. We're subtracting that, so 81 subtract 32 is 49/16. Does that reduce? It is positive. 49/16. Doesn't divide by 2, doesn't divide by 3. Does it divide by 7? No, I think it doesn't reduce. I think that's as far as it goes. What's the equation of the axis of symmetry in this one? So once again, the vertex is going to be negative, so positive 9/8, always the backward sign, and 49/16. So the equation of the axis of symmetry, that should be a vertical line right through the x value of the vertex. So x is equal to 9/8 is the axis of symmetry. Sometimes we call it AOS. Semicolon. Okay. Another one with fractions. So 20-2 people, you might want to try this with decimals instead. My 20-1 will try it with fractions. So first thing we need to do, doesn't actually say y equals, but we can write the y equals in there. We are going to common factor out negative 1/2. I'm going to do it in a few less steps now. I'll show you how I usually do it. Usually it only takes me about 3 lines, I think. So right away, I leave the negative 8 at the back, and I common factor the a, both in the first steps. That leaves behind an x squared. And negative 3 divided by negative 1/2. What's that? Means times negative 2, so it's positive 6. Okay, C star is 6 over 2 squared, which is 3 squared, which is plus 9, minus 9. So I do all of that in one step usually. I do my common factor, I write my new b value, and I find my c star, and I leave the original c behind. Step 2, I throw that guy out, and I complete the square into a single bracket. So y equals negative a half, x plus 3 squared. It's always the sign of the middle one, if you want to be kind of quick. So you could just take this one and divide it by 2. That's the safe way. If you're square rooting this, you have to remember to carry the sign from there. And minus 9 times negative a half is 9 halves, positive 9 halves, minus 8. And 8 we can rewrite as 16 halves. Then we simplify. Negative a half, x plus 3 squared. 9 subtract 16 should be 7 halves, I think. Yep. Negative 7 halves. So there's our completed the square. If you can do this, it doesn't get any harder. This is pretty much it. So the vertex is negative 3, negative 7 halves. What is the y-coordinate of the vertex? The y-coordinate of the vertex is equal to negative 7 halves. Y-coordinate of the vertex, maybe we'll call it. It's not good just to say y equals. You have to kind of say what you're solving for. Unless it's directly under the question. Usually it's pretty clear, but I usually like to write something there. Okay, example 2. Convert the function negative 5x squared minus 70x to vertex form. Verify that the two forms are equivalent, both algebraically and graphically. Graphically, you can do it with the graphing calculator. Algebraically, we're going to expand once we get the vertex form to see if it's the same. So y equals negative 5 as a common factor, x squared, negative 70 divided by negative 5. Should be able to do this in my head, but it's late in the day, is positive 14. There was no c value to throw away this time, so it actually is kind of easier. We're not going to need to simplify, but we still need to find our c star. So 14 divided by 2 is 7, squared is 49. So plus 49 minus 49. Get rid of the negative 49. Y equals negative 5, x plus 7, all squared. And negative 49 times negative 5, 245 positive. So that's number 1. We've got our second form. Now we need to verify. So check. Let's rewrite it, and we're going to expand. Why don't I write it out this way? Save me a step. So first thing I always do is I start with the FOIL, and I do the negative 5 after. That's just the way I always do it. You could rainbow the 5 into one of them, not both. If you do it into both, you'll have done something wrong. Negative 5, x squared, bracket. Plus 7x gives me my plus 14. That's why it's divided by 2. This number divided by 2 gets you that one, because it adds up with 2 of them. And 7 times 7 is my positive 49. That's why it's the square root of that one. Plus 245. Now we need to rainbow this guy across. Numbers are going to get slightly big. Negative 5x squared. Negative 5 times 14. Well, we already know what that's going to be, but let's check it with the calculator. And it is indeed 70, negative 70. Negative 5 times positive 49 is negative 245. plus 245. So those two numbers cancel out. And it just makes negative 5x squared minus 70x. So it does indeed work algebraically. We can get back to expanded form, so we can move both ways. And then graphically, so you can graph this original thing in your graphing calculator and have a look at what it looks like. And you can graph the vertex form as well, this guy right here. So he's going to have a vertex at negative 7 and positive 245. I have a vertex way up here. When x is 0, 7 squared. Actually, it's going to be right. It goes through the origin, isn't it? Should get something like that both times. Where this is 7, this is 245, and through 0, 0. So check with your graphing calculator, you've done the same both times, and you have your graphing calculator on the test. You can check your answers every single time. So there's no reason ever to think that you did it right where you actually did it wrong. The worst that'll happen is you know you did it wrong, but you can't find your mistake. So you can always check your answer, if time permitting, on your tests. Last question. Draw a graph of negative 2x squared minus 8x minus 3. If we want to graph this, standard form doesn't help a lot. You could use your graphing calculator, but let's try and graph by hand. Let's actually say that. Let's pretend we don't have technology to help us. We know a couple things about it right away. I don't have all my colors here, so I'm going to have to do it all in black. We know right away it's going to have a y-intercept of negative 3. So 1, 2, 3. We know it's got that point on the graph right away. We know it opens down, so it's going to be some kind of upside down parabola. We don't know where the vertex is. So it's actually not a lot of information to go off of. We could try to come up with a table of values, and I'm sure we would do a good job, but we can complete the square, and let's do that. Because it's actually not that hard once you've practiced it a lot. So y equals negative 2 is common factored out. X squared, negative 8 divided by negative 2 is positive 4x. And the minus 3 is left behind. Now what c value are we looking for? 4 divided by 2 squared is 4. Plus 4 minus 4. Get rid of the minus 4. Now you know why we were doing this all the time last time, even though it didn't seem to matter very much. When you have an a value, it really does matter. So next line, negative 2. I have my perfect square in here, which is x plus 2. And negative 4 times negative 2 is positive 8, minus 3 is positive 5. So we have the vertex at negative 2, 5. Not that much work. This is probably about the same amount of work as creating a table of values. And if you don't really know where the vertex is, if you end up with somewhere far off from your vertex, then it's going to be much less work to do this. Because you have to graph the vertex. Without the vertex, you don't really see the parabola. Okay, so negative 2, positive 5. That's that guy right there. So we have 2 points now. Do we have more than that? Yes, we do. Because of our axis of symmetry, straight down the middle here, we know that this other point has to be on the same distance on the other side. So that needs to be a point as well. So we actually have 3 points already. At this point, you could make a table of values, or you could kind of do the step method. I do like the step method. It is good to know. 1, 3, 5. Basically, when a equals 1 times a, let's just say. So the steps, as you move 1 to the right, it goes up by 1 times whatever your a value is. And our a value is negative 2. So as you move 1 to the right, it actually goes down by 2. Let's check that with the next one. So 1 more to the right should go down by 3. times negative 2 should go down by 6. One more to the right. 1, 2, 3, 4, 5, 6. Yes, indeed. So for us, the steps should have been negative 2, negative 6, negative 10. So if I went one more to the right, I go down 10. 1, 2, 3, 4, 5, 6, 7, 8. Ease off the graph. Let's not worry about that one. But we do have those points, and we can connect them. We can write the equation of it. Y equals negative 2. Now let's write the vertex form. X plus 2 squared plus 5. And label the vertex as negative 2, 5. Good. So that's the completing the square with an a value. Exact same method every single time. So this is one of those things on the test that either you do know it or you don't know it. Most students know it. Some students didn't practice enough and they just get all the questions with this wrong. So make sure you're in the first group. Make sure you've done enough practices, you've got the methods completely solid, and you're just going to get every question right. Okay, try the homework.